Day 581 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3432. Count partitions with even sum difference. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n. A partition is defined as an index I where 0 is less than or equal to I and I is less than n minus 1, splitting the array into two non-empty subarrays such that the left subarray contains indices 0 and I, the right subarray contains indices I plus 1 and n minus 1. Return the number of partitions where the difference between the sum of the left and right subarrays is even. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 10, 10, 3, 7, 6. The output is 4 because there are 4 partitions that we can create where the difference between the sum of the left and right subarrays is even. Those 4 partitions are 10 and 10, 3, 7, 6, right? So we could take this 10, split it up. We could split the array by this 10 and then this 10, 3, 7, 6, right? That's how we split it up with a sum difference of 10 minus 26. So we take this 10, we add all these together, 10, 13, 20, 26. So this 10, sorry y'all, this 10 minus this 26 is equal to negative 16, which is an even number, so that's one partition. Then we could split it right here with the 10, 10 and the 3, 6, 7. When we do it like that, the difference is this is 20, this is going to give us 16. 20 minus 16 is 4, which is even, so that's another partition. Then we could split it up like this, 10, 10, 3, which would be 23, and 7, 6 will be 13. 23 minus 13 is 10. 10 is an even number, so that's the third partition. And then the fourth partition would be 10, 10, 3, 7, which is 30. And then this would be 6. 30 minus 6 is 24, which is also even. And in total, there were 4 partitions. So just in case that didn't make sense, let's take a look at example 2. Example 2, our input nums equals an array of integers 1, 2, and 2. The output is 0. It says no partition results in an even sum difference, right? So if we took this 1 minus this 4, we get negative 3. That's not even. If we took these 1 and 2, that's 3 minus this, sorry y'all, minus this 3 minus this 2, that's going to be 1, and that's not even at either, right? So in the end, there are no partition results. No partition results in an even sum difference in example 2, so the output is 0. In example 3, the input nums equals an array of integers 2, 4, 6, and 8. The output is 3. That means there are 3 partitions. It says all partitions result in an even sum difference. So there's only 3 partitions we can create. We could do this, sorry y'all. We could do this 2 minus 18. That's going to give us negative 16. That's even. We could do this 2 and 4, which is 6. And then this 6 and 8, which is 14. 6 minus 14 would be negative 8. That's even. And then we can also do this right here, 2, 4, 6, which would be 12. Minus 8 will give us 4, and that would be even as well. In total, there is a total of 3 partitions we can create with a sum difference of that is even from this array. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult. Now, first thing we're going to do is we are going to create a variable called total, and we'll cast that as a int 64, set that equal to 0 to start, right? And we're going to use int 64 to safely accumulate large sums without overflow. Now we need to compute the total sum of all the numbers in the array. So we'll come underneath this, we'll say 4x n nums. We'll open up the brackets and we're going to say total plus equals int 64, open up the parentheses, passing x. Boom. Then we can come right here, sorry y'all, right here, And if the total sum is odd, it's impossible to split the array into two parts with an equal sum, so we can return 0 immediately. So to check that, we can say if total mod 2 not equals, exclamation point equals 0, meaning if we take the total divided by 2 and the remainder is not 0, that means it's an odd number, right? And we can't split it up into two parts with an equal sum, with an even sum. Or we can't split it up into two parts or different partitions where we can have a sum difference that is even. So we could just return 0 like this, boom, because this lets us know that the total will be an odd number, boom. Then otherwise, if the sum is even, we could just return it. For an even sum, every split point between elements is valid, except you cannot split before the first element or after the last. So the number of valid split positions is going to be equal to n minus 1. So we're just going to come right here and we're going to return nums.count minus 1. Boom, y'all. That's all she wrote. That's all the code. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.